Hey everybody. So yeah, I'm going to be talking about strategies for managing your monolith and transitioning to a service architecture. This talk is going to be a wide-ranging discussion on like scaling a monolith and ownership and strategies on moving towards service architecture. There's going to be quite a few topics that we'll cover. I'm going to aim for like a breadth of topics and not get in too much depth on any in particular, but feel free to ask any questions. A little bit about me, I'm a principal engineer at Kanji, Apple device management company. I've been doing Python for over 10 years and have helped some companies to scale. And I've been in Python web, like open source communities for over the years and mostly in Flown, but kind of been around. So yeah, to start off with, so if you're at the point where you think you need to decompose your monolith, that means you have a successful product because you're seeing some issues with scaling. It's either scaling the product from a technology standpoint or like you're trying to build the team and managing a monolithic code base is difficult to do. So it's a good thing. It's a good problem to have. Okay, so what do we mean by a monolith anyways? So a monolith is a way to refer to a system that is like a single large component that provides most or like all the functionality of your system. You might consider it maybe the anti-microservice. As a company grows, scaling and managing the complexity of the monolith can get more difficult. Monolith versus microservice can often be more about like the delivery and ownership of your product, and but you're still building software, and the logical boundaries of your software that you're building might turn into physical boundaries with microservices. But many of the problems around scaling a monolith have to do with the patterns used in the monolith, not necessarily the fact that it's deployed as a single unit. So before we begin, I just want to I want to point out, like, you don't want to rush into building different services, or you might end up in a mess that's worse than the monolith. It's okay to keep building on the monolith while you're figuring out strategies for transforming the existing architecture. And many companies are built on monoliths or core components that are large. It's quite normal. And ripping apart a monolith is pretty difficult and takes time and care in a live, like, active system. So do it with care. And first off, identify what are the actual problems that you see in the monolith. Don't just do it because microservices are cool, or you have to make an informed opinion or decision on why, like what benefits you're going to have by moving out of a monolith. Can you deploy faster? Can you scale horizontally better? Is it better for teams to take ownership of the software? Like, there's a lot of different questions and reasons you can have there, or splitting your monolith into different services might be of benefit. But there is no free lunch. There are advantages to having a monolith. Some problems can get more difficult when you're moving out of the monolith. Some things are harder to debug and understand, and you have to do things. Everything's a trade-off, right? So own the monolith first. Before you start ripping everything apart, embrace the successful product that you have. Like, own it, understand it, and support it at scale. Do not make the mistake of thinking that you should rewrite things. If your team is growing a lot and with new members learning about the system, you might have people saying like, hey, we just need to rewrite this. This doesn't make sense. That's usually a bad strategy, in my opinion. Basically what you're saying, if you want to do, actually, okay, I'm sorry. I just realized that maybe there was a different slide showing than what I was expecting. Sorry. Yeah, so do not, anyways, if you say you think you need to do a rewrite, it's basically saying that you can't understand or support the current software that is serving your customers right now of your successful product. And you're like telling, your managers, hey, give me 6 months to rewrite this or whatever amount of time period you think, and everything will be great after that. And then I can support it and do a good job. And then once that deadline happens, you probably didn't meet it because other things are happening and you're still supporting the current system anyways. And you'll ask for another 6 months. And then once that 6 months happens, maybe you failed, maybe you succeeded, probably failed, and you moved on to another job. So don't rewrite, it's usually not the answer. Give the current system love, refactor it, add tests to it, think like, what is the CI/CD situation like? Is every PR automatically tested? What is your testing strategy and product delivery strategy? There's so many things that go into producing and delivering software effectively that should be addressed before you think about going into microservices. So ownership, what do we mean by owning the monolith and supporting it at scale? We mean understand how it behaves at scale in production. It means to really understand how it behaves at scale in production. So make sure that you have very good observability on your system. It's going to be very important when you move to microservices that you have observability. You'll have a nightmare if you don't have good observability in place. So do it first with the monolith, and it'll help put you in a better position if you have the patterns and systems in place to be able to move to your service architecture. So this is like observability on your application, but also your database and networking layers. If you're using Kubernetes, you want to know all parts of your system. Some great tools that are available are things like Datadog. Honeycomb is a really cool product. I haven't used it myself, but it looks really promising. New Relic, and then Sentry. Sentry is, mostly for error handling and stuff, but still a good tool to use. And a lot of these tools give you libraries to automatically patch all of the modules that should be traced. So all the database interactions, all the interactions with third-party services. A lot of these, like Datadog and New Relic, give you things that will automatically patch those for you. There are, well, we can go over that anyways. I would advise not to roll your own if you're younger. It can get really difficult to support and expensive. Usually it is a better investment to just use a service for observability rather than trying to do it yourself. You won't do it as well, and you'll be thrashing around having to support that observability yourself. Tracing, make sure all interactions with any different system are instrumented, like every network call, for example, and can't add custom instrumentation where necessary. There's a lot of those libraries to automatically patch your application and add tracing everywhere will not work with Python async IO, for example. So you'll have to maybe roll your own tracing in those cases. Some other types of tracing that I found are needed are knowing the in-flight requests that your application is servicing at any moment in time, the connection pools that each of your imagine that you're load balancing, and each application has its own connection pool, getting some observability into the size of those connection pools and utilization is usually really important. Queue lengths and DNS requests often aren't covered either, but you can be bitten by slow DNS and issues around DNS as well. If you are having trouble scaling, often it is around the database, and having one monolithic, scaling an application is often easier because you can just load balance between many replicas of your application, but databases often have more difficult constraints around scaling. So really understand how your database is utilized. It's likely the main issue around your scaling. Make sure you have alerts set up and that you're supporting your system. Do customers tell you when there's a problem, or are you telling your customers when there's a problem? That's often a good metric to know if you are supporting your system correctly in production, a simple metric. So, integrate on call, like something like PagerDuty or similar to tooling. And how's your CI/CD? If you can't effectively test and deploy your monolith, how are you going to do it with many services? How long does it take to make a release? How many teams are involved? What's the testing like in order to make a release? How long does it take to roll back a release? These are things that you'll want to think about and make sure to nail down in your monolith. How are you scaling your monolith? What is the auto scaling policy for handling load? So if you're using Kubernetes, what are your HPA definitions and all your different components in order to scale the monolith? And how's your database scaling? If your database is having trouble, you can use simple things like read-write splitting. If you're on AWS and other providers, sometimes they'll provide like automatic read-write splitting for things like Postgres. And then are you using database connection proxies in order to manage having like a lot of connections to the database? These are simple things to help you to scale. And if you think you need to move to a service architecture, it's often because like the current monolith is getting too large and complex, right, for multiple teams to work on. So it often comes down to so your monolith problems often come with ownership problems of the components in the monolith as well. So some strategies around that is making sure that all the modules in your monolith have identified owners of, and starting to untangle like underdefined relationships in those modules, and if there's any modules that there is no clear ownership, untangle them, refactor, and start thinking of your monolith in a I don't know, decouple. Well, we'll get there, I guess. I don't want to get ahead of myself. And another tool to use is GitHub's CODEOWNERS file. This allows you to specify owners of particular parts in your code base that will automatically be assigned to review changes to any of the code within that section part of your code base. All right. So how do you prepare so imagine you're supporting your monolith in production now. So how do you start? You're supporting it well and you're owning it in production. How do you start preparing it to split and to move into a service architecture? So one thing we want to watch out for is we don't want a distributed monolith. We don't want to just split things up for the sake of it. We want to be careful about how we build our systems, because what you end up with might be worse than the monolith. It might be worse than what you started with. What we want to aim for is something like a decoupled monolith. And what we mean by that is like isolating the interfaces between components in the system, refactoring your code, creating logical boundaries between the systems in your monolith, and identifying like angles that are tangled up with no clear ownership and that are difficult to refactor. Our monolith can mimic the eventual service architecture. And think about service architectural design. So one pattern I've used for service architectural design over the years is something called domain-driven design. Domain-driven design is attempts to like help you build services that are loosely coupled but still cohesive. It's like a set of patterns to help design software systems based on the underlying business domain. And one of the guiding principles is single responsibility principle. Gather together the things that change for the same reason, separate those things that change for different reasons. So when you have a monolith, it might be difficult to know all the functionality ownership in different domains of the infrastructure, because this thing, or of the product, because it's been built over years and might be messy. And so there's this practice called event storming that brings in many stakeholders of an organization to help you identify all the domain areas and organize them and put them together in a way that can help you to visualize maybe what the different domains are and eventual, like what teams could own to help you to understand team ownership and maybe eventually understand like, okay, this could be a service in itself because it covers all of this domain, and it would make sense to start there. What you do with so event storming also, like, don't confuse it with like event driven or pub sub or anything like that. It's just it's a way of, like, you describe events as like things that happen on the system, and it's just a way of describing things that happen on your system. And so maybe the naming wasn't great, but that's what it's called, is event storming. But it's pretty simple. You just start with like, hey, user, something happened. So in this case, example, user changed his password. What happened? Password changed. And in response to that, email the user that the password has changed. You start like building a bunch of these actions, and you can put them on a whiteboard with stickies like this, or you can use Figma. This is a screenshot of something we did at my company. And you can start grouping them into different areas, domain areas, all the different actions that you have. Anyways, it's a good tool, and it can at least help inform you. And if you have the time, and especially if you have new engineers and stuff, it like really helps bring everybody together into understanding what your whole system does. So another thing to think about when moving to a service architecture is data ownership. You probably have, if you're in a monolith, you probably have one database. In a service architecture, each service domain should have its own database. So you don't want to share databases between services. It can be a short-term strategy for when you're trying to split a service off, but you want to long-term, you want to split them, have each service domain have its own physical database. So for example, what we mean by domain in an example, say user service or something like that, it might include an HTTP API, a GRPC service, and a worker for like a queue, or something like that. They might all connect to that database, but that still is encompassed in that service domain. So you can imagine, especially during decomposition, foreign keys could be a problem, because if you're using Django's ORM, you probably created foreign key relationships all over the place. You probably did on-delete handling cascade, or on-delete cascade handling, so all of your foreign key relationships are automatically cleaned up for you. When you are decomposing and separating these data layers, you don't get that for free anymore. So those are going to have to be moved into, say, an event that's subscribed, and that the foreign key relationships are going to have to be managed at the application layer instead of at the database layer, which is not a bad thing. It makes things more complex, but on-delete cascade is a really hard thing to scale. Everything in a transaction for on-delete cascade can be very taxing on a database depending on the workload. You also potentially lose joins, because these are different databases. There are strategies around that too, as far as like data composition strategies we'll go over, but joins at the database layer you will no longer get, and you might have to do those at the application, or design your APIs differently. And another thing to think about, especially with domain-driven design, is this concept about bounded context. If you build one service that needs access to another service's data all the time, you might have like designed something incorrectly, because say like if you, for example, have a user might have various settings on it, and maybe you were inclined to have a user service or something like that. If you have a feature, requires some setting associated with the user in order for that feature to be enabled or performed differently, you might think, oh, I'll just tack another property onto that user object and then call that user service all the time whenever I need to know that data. That might indicate that you've done something wrong. Like the context of that feature involves like sort of this soft reference to that user with that setting for that user, and that actual data on that setting or whatever it might be on the user object instead. I don't know if that's a good example, but I'm trying to think of something on the spot to describe what bounded context means. Anyways, like I said, breadth, not depth. Another thing to think about, especially in a lot of the frameworks that we use in Python, but in all the other languages too, it's common for the ORM to creep all over the monolith or the software. And that means your ORM, your mapping of properties on the database often leaks into all the implementation details of like APIs and stuff like that. So your data layer ends up being kind of tightly coupled to your maybe presentation layers and things like that. And so if you wanted to ever move to another database or whatever, or change the underlying implementation for the database, you might have problems because the ORM is littered everywhere. So try to avoid that. Try to avoid API coupling with your ORM. So create instances of like abstract data access. And so abstract the data access details out, create concrete interfaces in order to access that data. So this is like a Django example of where this might happen. You have products, reviews, users, and you have all the relationships, and then you might get all the reviews and serialize the whole object and dump it all out. Now your API is tied to your ORM definition. Write clear interfaces between components that are not, so anyways, we kind of, write clear interfaces between your components that are not tied to your ORM. Separate the domain objects from the ORM tables. So anyways, once you get through all of that, start small, find a component with limited functionality and exposure in the monolith, and use that as like your first dabble into breaking things apart. An example, in the last two companies for me, for example, it has been something like an activity stream. Often has events, that need to be stored to a table in a database. Something like that could easily be pulled out where you're publishing events to a queue somewhere that are being consumed and saved to another database, and then the API is exposed apart from the monolith. So some tooling and techniques that you can use for decomposing your monolith once you have all of these other things in place is first off, an API gateway is a really important tool to have in place. What an API gateway allows you to do is like publish routes from various services. And so if you have multiple APIs, you can compose them all into one API, one route, or excuse me, one API that's mapping the different sub paths or exposing multiple APIs. Anyways, this unifying layer between all your services and how you publish them. They usually provide advanced load balancing, like with retries and circuit breakers. And sometimes you can also use your API gateway to do authentication at that layer. So then when your downstream service ends up gets the request, that downstream service can know, okay, this request has already been authenticated. And so how you can do that, or you can use like OAuth with JWT validation. So if you're using things like, I don't know, auth0 or something like that, you can do that authentication at the API gateway instead of at your downstream service. So like if the request isn't authenticated, you just never see it, and then that downstream service doesn't ever have to think about it. And so another thing the API gateway can do is, if the authentication is successful, it can also annotate that request with, say, like the user ID that's making the request, the roles that that user has, and just other things, roles and permissions, scope, all those other things that that downstream service can then use to make authorization decisions. You can have API gateways that integrate with authorization systems. I guess I wouldn't recommend it. Managing like the definition of which endpoints have what authorization characteristics and things can be complex. And at least in my experience, I would recommend the authorization always being responsible of the downstream service. So like they have the user ID, they have the roles that the user has, and they can make the authorization decisions themselves. Another thing that many API gateways, not all, but many can do for you is they can also authenticate and encrypt traffic between different services. So if you have internal services that are communicating with one another, instead of having to roll your own internal like auth framework, they can provide automatic TLS encryption and authenticate the interaction between those services. Anyway, so with all that, some different tools you can use for this, and sometimes you'll use multiples of these tools, is things like Istio, Ambassador, Kong, and even Nginx is still a fine API gateway. Like some of the things aren't as like new and nice with Nginx, but it has a lot of what you need often, and maybe it's a good place to start. So the next thing to think about is API composition. And what I mean by API composition is if you have an API, often you have multiple properties of a particular, like in a response that might maybe do joins on data in order to like give it a rich response. And so often, so that might require pulling data from many systems in order to provide all the data composition you want. So something that used to be in the monolith and did joins to be able to compose the result that you wanted might not be so easy to do anymore when you're in a service architecture, because these are separate services now. There are tools to help you facilitate this. So imagine that we have like a product that has reviews, users, and we have an application that has products, users, and reviews. And so we decided to split those out as separate services. But we have an API that we want to return the results of the reviews, and we want to have the review body, the product name, and the user that made the review. And so if these are all in different services, how would we do that? We don't want something like this where you have all these like, you know, circular dependencies maybe and complex relationships between all of our components. What do we do about this? There are like a number of different approaches for managing this kind of situation in order to like prevent us from having these complex relationships. One of those is something like Apollo API, or excuse me, Apollo GraphQL Gateway. This allows you to have like separate GraphQL services defined that are all stitched together into a single gateway. So you can define your GraphQL graphs separately, expose them separately, and they'll compose into a single API, GraphQL API. And you can even do foreign key relationships with them. So it will do like the joins for you kind of at the API level instead of at the database level. And then compose it into a single result. Another approach is something like Krakend, which is an API that it's an API gateway that allows you to merge the results from multiple JSON APIs together. It has a lot of other features too, but that's kind of like the core idea. So you'd be connecting to multiple APIs, and it's composing the results together for you into a single API. So that's good, especially like when you can imagine, I don't know, your front end teams might need to make like, you know, a dozen API calls in order to compose one page. Well, maybe if there was one API that did the composition for you, it would be less network trips and be a lot more optimized. So another thing you can do is provide your own high-level compositional API layer, and that would just, you know, have a simple relationship to all the all the downstream services, and then do whatever kinds of joins or whatever is necessary at that level, at that layer as well. You might be tempted to do something like this in the monolith too. Try to avoid that if possible. So the next kind of tool that you should consider investing in is event publishing and data streams. There's a nice way to decouple behavior in your systems. You know, like when something happens, you know, publish an event that can be subscribed to by other systems. So example, user joined event, publish it to the data stream, and then other services can subscribe and do things when that event happens. Like tools like Kafka and Nats are really good. You can even get away with it with if you're on AWS and you want to use SNS, you can send SNS messages and then have subscriptions that do something with those messages based on like criteria of data in those messages. I think the most important thing to consider when building these systems, like separate systems, is having good contracts between your systems and using tools like Protobuf, Avro, JSON schema, or shared types in order to like communicate those contracts between the systems. So make sure they're like machine readable, make sure they're contracts that could be enforced at build time with CI, so that any changes that are done to them can be tested and all the dependency services can be validated for any changes. GRPC is a good technology as well for this. You define your types and your service in Protobuf, and then you can generate the clients to be able to connect to that service for any language, and you have the strong typing support and everything. But you can also use REST if you need to. I guess the caveat with REST is I would recommend to always publish the client implementations for that system in a through a shared repo or something like that. You always need to communicate the implementation and strong contracts for that system. Like JSON or OpenAPI is fine, but OpenAPI is not built in so much to like it's not like GraphQL. You can incorrectly define OpenAPI and there's nothing that's going to enforce it completely for you. So it's just one of the caveats. Maybe make sure to build a client implementation. So as the logical boundaries in the monolith are translated into physical boundaries, like performance characteristics also change. Network IO is not free. So especially with Python, remember, if you're moving to a service architecture, the network IO can be expensive, because if you're serving your app in a threaded way, now you're doing all of that thread context switching kind of stuff for network IO all the time. And you probably end up having to scale to a lot of threads, which isn't great for Python. Python's not Node. Even with async IO, it's not the same. So it's just something to think about as your moving to physical boundaries between systems dramatically changes how your application performs. Again, remember the tracing is really important to have in place. Something that is available to you is GEvent. It's like this magic library that will automatically monkey patch all the network layers, and even like threading, like it turns threading into not being a real thread. It's kind of crazy. But developers will likely not understand what's happening magically under the hood so much, and you could still have CPU bound code problems. And I definitely recommend against only using it in production, for example. Like you might be tempted to, I don't know, deploy in production Unicorn with GEvent, but not have that anywhere else on in your stack, whether your development stack, or not have it in your test, like as your part of your test framework where you're running with GEvent activated. I wouldn't recommend that. If you're going to buy into it completely, and not just as like a deployment artifact. There is also async IO available, and it's great. I love it, but I've used it a lot. But it still seems like a pretty niche skill, and not all engineers will be very well versed in it, and they might make a lot of mistakes in using that. So one other thing to think about with the monolith is it's really easy in a monolith to do multiple operations in a single API endpoint and just wrap that in a database transaction. So if anything that fails within that thing, the whole database transaction gets reverted and you're fine. So if you're splitting things into many services, this might not be doable anymore. And it's not a trivial type of thing to do. Doing distributed transactions is not trivial. It takes a lot of work, and there are patterns. Like one of the patterns is called SAGA that you can use for distributed transactions. I'm not going to get into the details, but it's just something to keep in mind, the trade-offs of a monolith versus service architecture. A really important part of your monolith and service architecture strategy should be providing shared tooling between all your services. It's like tooling to set up logging, configuration loading, instrumentation, and just the interfaces between the different components. You don't want each system doing their own thing in this case. So monorepo is another strategy that tends to kind of reduce the churn around like deploying and maintaining many components, but it has its own drawbacks, and operationally is often harder because so many of the tools that you use for, say, CI and stuff like that are often provide a one-to-one like relationship between the repo and the deploy target. So you'll end up fighting tooling probably with that approach. But it's something to think about. And finally, one thing to think about with your applications is to standardize the deployment of their systems. Is there's a concept called 12-factor applications, and it's a standard for deploying systems in a way that is consistent, like around how you manage the code bases, deploys dependencies, so the concurrency models and processing models, and handling logs. So like environment variables is really important to get in, like you're going to be configuring your systems all through environment variables in the 12-factor model, and getting those consistent between components is really important. Same thing with logging. Likely your logs on your systems are streaming to, standard out. Well, I recommend, adopting structured JSON logs so they can be, read by Datadog or an Elk stack, and you can search through them and get meaningful information out of them by having like structured JSON logs. So anyways, with that, are you ready to take on your monolith, like own it at scale, support it in production, and design scalable services? Anyways, that's up to you guys. Thank you for your time, and yeah, I'm interested to hear if there's any questions. Thanks.
Yeah, we have a few here. First one we have, how do you determine what should qualify as a service in a microservice architecture?
That's probably a contentious question. It depends. Like a service could be, I what I like to call them, like how I like to describe them is in a domain. And so that's the domain-driven design approach. And so domain can be multiple different components. It can be an HTTP service or a gRPC service and like a worker, but they're all encompassed in a domain. And that's like a team would own that domain, and you could have multiple workers, multiple APIs potentially in that domain. It depends on what the context of that domain is and what you're trying to accomplish. Like you can even imagine, I'm not necessarily saying I'd want to do this, but if you wanted to adopt like serverless features from AWS or something like that, you would still have multiple APIs that you're exposing for a particular domain. But those are all like separate APIs, and still, you're exposing separate endpoints there. I hope that helps. Makes sense a little bit.
All right, next question. Is there any best practice to handle eventual data migration when dealing with different and connected DBs?
Best practice. I don't know. There's a lot of different ways to do it. So managing the migration, right? That's what you're trying to do. So if you want to do it live, that makes it complex, right? Because you have to keep two systems updated simultaneously. There are things you can do, like if you can move all your writes to a queue that both systems can read from and do the actual physical writes, that is a strategy you can use. Or if you can start off by replicating all the data from your database into like using a different mechanism to do the replication, so the writes are going to one place, but but in that scenario, you're just working on moving the data, as part of your strategy for moving. So replicate all your data, still have the writes going to one place, and then do a cutover for writes once the data is all over. If you can have any downtime, that would be an advantage. That's probably a big discussion in itself, because every system is going to have different characteristics that would dictate what would be a better strategy for moving data. It's not easy though. Nothing's easy.
Nothing worth doing. All right, next question. Since multiple services need to talk to each other, presumably using some sort of RESTful API, what would you say the overhead, like TCP connections, is worth it? Or would you say the overhead is worth it?
So you're saying, if I understand the question is, the context is multiple things are communicating over REST. I mean, I don't know. It depends on your load or your scale. I mean, it depends on the complexity that you want to like manage. If your scale is fine and you don't have the complexity, I don't know. It depends. It always happens. And if you want to keep using Python, there's always, I guess, limits, because Python is not as fast as, say, Rust, but we're all here using Python and have been able to use it to a reasonable scale, and we're not Google then, so I think it's probably fine. I don't know what. Maybe come to face and we'll kind of dig into that question more.
All right, last question. How about AWS API Gateway? Is it comparable with Istio, Ambassador, Kong, Nginx, etc.?
I haven't actually used it. I prefer cloud native API gateways. For the past, I don't know, while I've been doing Kubernetes, and so like I've always tried to use cloud native services. If you are like heavily invested in AWS, then it probably is fine. But yeah, I haven't actually used it. I have coworkers that are interested in using it now, but I guess I'll let you know.